So we just got finished proving on number 5 in your notes what is known as the consecutive interior angles theorem, which states if you have two parallel lines that are cut by a transversal, then we know the consecutive interior angles are supplementary, which means they add to be 180 degrees. The converse of that is also true, and we will prove that eventually as well. And it states that if you have two lines cut by transversals so that the consecutive interior angles are supplementary, then that means that your lines had to be parallel. So again, when a statement and its converse are both true, you could write that as a biconditional statement. All right, question number 6 in your notes says we have found relationships between angles formed by parallel lines cut by a transversal. So we're going to see if we can use those relationships to solve this problem. So in this diagram, we have two pairs of parallel lines. We know J is parallel to K, and we know line L is parallel to line M. And so we're asked to find the value of X. So obviously, we only have two expressions in this picture that contain an X, 4X and 5X. And we know that we only have two relationships in parallel lines. We know we have congruency, and we know we have supplementary as a relationship as well. So we need to be able to justify which one of those is true here. Now I can tell by looking that obviously 4x is an acute angle and 5x is an obtuse angle. So it certainly wouldn't make sense to say these are equal to each other. Obviously also, what number would you be able to multiply by 4 and by 5 and them be equal? Well, it'd have to be 0, and that wouldn't make sense. That would make those angles 0 degrees. So obviously these two angles are supplementary, but we've got to be able to explain our reasoning. We've got to be able to justify why we know they're supplementary. Now there's lots of different ways that we could go about doing that. One way would be for me to say this angle that's 4x degrees is a corresponding angle to angle 8. They're both above line J and they're above their line. 8 is above M and 4x is above or to the left of L. So they're in the same relation to both lines, then they are corresponding. So the 4x and the 8, angle 8, would have to be congruent. So I could also say 8 is 4x degrees. I could use another pair of corresponding angles with 8 and 12 to say if 8 is 4x, then 12 has to be 4x because they are corresponding angles and they're congruent. And now I can say angle 12, which is 4x, is a linear pair with the 5x. And I know linear pair are supplementary. And so I would know 4x and 5x are supplementary, add them together, set them equal to 180 to solve for x. Now that is certainly not the only way that I could go about doing that. Another way I could go about is say, well, the 4x here and angle 3 are vertical angles. And I know vertical angles are congruent, so angle 3 has to be 4x as well. I could say that angles 3 and 5 are consecutive interior angles, and so they have to be supplementary. So angle 3, which is 4x, and angle 5 have to be supplementary to each other. Well, angle 5 and angle 5x are congruent to each other. So if 3 and 5 are supplementary, 3 and 5x are supplementary. So that's another reason why I could say the 4x and the 5x are supplementary, which means they have to add to be 180. And I could go on and on and on with different ways of showing that these two angles are supplementary. So as our work on number 6, we would add the 4x and the 5x together and set them equal to 180 degrees. So 4x plus 5x is 9x. Dividing by 9 on both sides would make that be 20 for the value of x. So again, lots of different ways of getting there, but the result should be the same for everyone. 4x plus 5x equals 180. And then if we know that we have lines that are cut by a transversal, remember we have many pairs of angles that are formed. We have 4 pair of corresponding angles. Those are 1 and 5, 2 and 6, 3 and 7, 4 and 8. We only have 2 pairs that are known as alternate interior, opposite sides of transversal, inside parallel lines. 3 and 6 are one of those, and 4 and 5 are the other pair. We have 2 pair of alternate exterior, That's outside the parallel lines, but opposite sides of the transversal. That's 1 and 8, and 2 and 7. And we have 2 pair of consecutive interior, same side, inside. So 4 and 6 are consecutive interior, and 3 and 5 are consecutive interior. Now remember, these angles exist anytime you have 2 lines cut by a transversal. It's just they will only have the special relationships of being congruent and supplementary when the lines are parallel. If we look at our final question on the notes, number 7, it tells us to use our conjectures, which we've proven many of them, so they're really theorems at this time, and the related converse statements to solve this problem. It says, suppose you work for the Department of Transportation and you're planning for some new streets. How could you use your knowledge about the angles formed by parallel lines to ensure that E Street is parallel to West Street? And again, there's lots of different ways that I could go about saying that I could prove East Street and West Street are parallel using special relations. One special relationship I could use is the relationship between angle 6 and angle 2. Since they are both on the right side of the transversal, which is our blue line, and they are both above the street line, 6 is above West Street, 2 is above East Street, then we call those corresponding angles. So if I had this angle already with West Street intersecting Northeast Street and made angle 6, then if I could create a congruent angle here at angle 2, then that would tell me my lines are parallel. Because if corresponding angles are congruent, then the lines have to be parallel. I could have used angles 1 and 5 as my corresponding, or 3 and 7, or 4 and 8. And I could have used alternate interior angles. I could have used angle 6 and 3 being congruent. So there's lots of different ways to go about this. You just want to have one of those special relationships in order to form parallel lines. So the example that they gave, it looks like, was the one that I started off with. It says one method would be construct West Street and Northeast Street so that the measure of angle 6 is known, and then construct East Street so that angle 2 is the same measure as angle 6. And since those are corresponding angles and congruent, then that would mean the West Street and East Street had to be parallel. All right, so that concludes our notes. And so if we look at our wrap-up question for today, it states, if 2 non-parallel lines are cut by a transversal, are the alternate interior angles congruent? And I hope you understand that that would be a big no. Okay, so if you have non-parallel lines, you still have alternate interior angles. Don't get me wrong. It's just they wouldn't have this relationship of being congruent unless the lines were parallel. So if they're not parallel, these angles are not congruent. All right, go ahead and do your assignment 6.2.